Hey everyone, Mr. Allen here. We're just finishing up our differential calculus section of the course. So the last thing, or last couple of things we'll be doing, basically applying all the derivative work that we've done to sketching graphs and then to optimizing word problems. So I've got the word sketch here, graph. Like we're at the point now where our graphs, or the sketches, whichever one you want to call them, are pretty close to graphs. We're going to have enough information that we can do a really, really good job with our graphs on something like a polynomial or a rational function. We're kind of extending on what we saw in the advanced functions course and kind of improving upon it at this point. Just sort of quick comment here. If you think about what you were able to do in functions class, we would often end up with graphs where we had, asymptotes and we maybe had intercepts or something. And so we know that maybe in this case, our graph kind of came down through here, came back up through here, hit that point, and then maybe we knew there was a double root at this point. We had some sort of a, what is that, 1, 2, 3, fourth power expression. But if somebody else were to draw the same, sort of get the same information and draw it more like this, essentially we said that that was the same graph at the end of functions or advanced functions because we didn't have a way to determine kind of how far down or up these sort of sections of our graphs went. So of course that's what we've just been seeing recently, and we're going to kind of put all that together right now. So I've posted an algorithm for curve sketching. This is kind of a step-by-step process of things to think about as you go through. So before beginning determining discontinuities within domain, so just problems that we'll have with the graph that are specific not to graphing in general, but into this question in particular. And we talk about division by zero, negative roots, sort of the kinds of things that might just happen. And then sort of thinking about what do we know given the question that we have. So it's sort of just a general look before you leave. Think a little bit before you actually start getting work done. And then we've got kind of 9 steps to go through. The order isn't exactly perfect. Certainly we could do intercepts before we find asymptotes if both are going to be there. But it sort of gives you a pretty good idea of which to do in what order. So when I look at this, I see I have a cubic function first of all. So clearly this is going to be a polynomial, the general shape of which will be kind of something along these lines. I know it's cubic. Thinking back to functions again, it's a positive coefficient out here. So this is the general shape of it. That doesn't matter too much, but it's a good idea to sort of have that in mind. And so what am I going to do? Well, I'm going to factor this to make it more usable, and that will allow me to find things like intercepts momentarily. The order in which I put these, again, vertical asymptotes first, and then sort of number 2 here is determine what happens around the vertical asymptotes. We'll get that into a second example momentarily as well. So vertical asymptotes in this question, there are none. And so finding out what's going on around the vertical asymptotes is not applicable because there are no vertical asymptotes. Of course, vertical asymptotes are when our denominator is 0, and there is no denominator in this question. Intercepts occur when either x is 0 or y is 0. So in the case of x being 0, I have 0 times, so 0 times -1 times -4. Obviously the y is 0, which means that the point 0, 0 will be on my graph. And then we need to see, are there going to be other x-intercepts in this case? If we make y 0, that's going to occur when essentially I solve this. So x can be 0, or x can be -1, sorry, not -1, x can be 1, or x can be 4. And so let's go +1 right here, 2, 3, +4 out here. So those are my intercepts for this question. maximum minimums. So essentially I need to take the derivative, again following through here, determine critical numbers, so maximum minimums, and sort of 4 and 5 go together to determine where we have maximum minimums. And so we have to set f prime to 0. So our derivative is this, using simply power rules here, 3x squared minus 10x plus 4. And we make that equal to 0. So we're solving again for the maximum minimums. As far as I can see, this can't be factored easily, so I'm going to go ahead and use the quadratic formula. And when I do that, I find x values of these two numbers. In order to establish where those two numbers are on my graph, I'm going to need to know what the y values are. So back into the original equation, so all the way back into f at x, I plug these two numbers and I find these two values. So that means that the points 0, 4, 6, 5, comma 0, 8, 7, 9, and 2.869, comma negative 6065 are on my graph. Now, knowing that's not quite enough, I would need to know whether these are maximums or minimums. So I'm going to go plot those. I'll be right back. So now looking at this, I'm trying to plot those 2 points. So this is 1 here, so 0.465 is about halfway, and up to 8.879. So my 1 point is about here. The other one was at 2.869, so 2.869, and negative 6. So I need to drop down here a fair bit. And so we're going to actually adjust this and pretend these are all 2's and go to 1 to 2.866, negative 6.065, so somewhere around here. And we'll call this a 2, so it's down around there. Now, recognizing what I know already, and that this is a cubic function that's going to go kind of up and down and then back up again, I basically have what I need to know to get this graph drawn. Two things though. I still want to figure out, just kind of show the math for this purpose of being marked correctly and so that I know how to do it later on, whether these are maximums or minimums. So if we kind of go all the way back down here, what we're interested in again is really whether these were maximum minimums, not based on the fact that I happen to choose a relatively easy example, but the fact that I can do the math to figure these things out. And so the two key points are the zeros, the 0.465 and the 2.869. And what I know is, again, these are going to be maximum minimums, which means either my graph is going to decrease until it hits that point right there and then increase afterwards, or increase to that point and then decrease afterwards. Okay, so again, this is what we did during the critical number section, critical point section. And so now I'm looking to just determine, is my slope decreasing to that point or increasing to that point? And like all the testing we do, it should be pretty straightforward. I'm simply going to pick a number that's slightly smaller than this and slightly larger than this and determine what's happening at that point. And so two really nice numbers here, f prime at 0 and f prime at 1, because those are on either side of this point. And again, it's f prime specifically because I want to know, is the slope increasing or decreasing? When I put the 0 in here, I get positive 4. When I put the 1 in here, I get 3 minus 10 plus 4, which is a negative value. And so I can see clearly now my graph is increasing, so the slope is positive up to that point and then negative afterwards. This is a maximum. Similarly, I can check f prime at, let's say, 2 and 3, and f prime at 2. All I'm trying to do is figure out, do I have positives or negatives? So this is 12 minus 20 plus 4. Looks like that's going to be negative. 3 would be 927 minus 30. This one's going to be positive. And so here I'm decreasing to that key point and then increasing afterwards. Now again, from my graph, and given the fact that it's a fairly simple one, I did know that already, but I do want to make sure I show the work, and I want to make sure that I know how to do the work so that later on I can do it on a more complex question. So, maximum minimums are established. Determine horizontal or oblique asymptotes. In this case, of course, I don't have any. Again, when we're looking for horizontal and oblique asymptotes, we're comparing the highest, or we're comparing the degree, let's say, of our numerator to the degree of our denominator. There is no denominator. Determine end behaviors. So what happens way out on the left and way out on the right? I happen to already know this because I don't have a horizontal or oblique asymptote. I know I'm just going to kind of continue on up and down. I know it's a cubic function, so I've sort of thought that part through already. Okay, so the last step is now to check concavity and inflection points. So this is my double prime, looking at, this is f prime up here, multiply through, subtract, 6x minus 10 is my equation for the second derivative. And if I solve that for 0, I find there's an inflection point at x equals 5/3. Putting 5/3 into my original formula, I find that the point, oh, I cut it off here. The y value is approximately negative 2.6. So negative 2 point is actually 593 or something like that. So basically this is where my point is. Now I need to know again on the left and the right of that point, that's where the inflection occurs. Is my graph going to be concave up or concave down on either side? And so into the double prime, putting a value of 1, if I put a 1 in here, I have 6 minus 10 is a negative concavity on this side, and hopefully when I put a 2 in here I get a positive concavity here. My inflection is then going from a downward or concave down to concave up, and so negative 2.6. So this is 1.5 right around here, 1.6, and I've got negative 2.6, so this is 2.6, so right in here is my inflection point. And so now I have my entire graph laid out, or I have all the information laid out. Again, sort of knowing that it's a cubic, it kind of fits with what I was expecting. My curve is going to come up through that intercept, turn around at that point, and then the inflection here, see if I can do a slightly better job. Up to that point, my curve is still concave down. At that point, it starts to curl to be concave up. And as much as I can't draw it very well freehand, that is my curve. So I'll do one more quick example momentarily with asymptotes. I won't finish it because you've sort of seen all the other steps, but I'll put the asymptotes into the second video.